Hello, I'm Phil Beecher, President and CEO of Ysun Alliance. I'd like to welcome you today to this open house. I'm sorry we can't meet in person, but hopefully we will be able to at some time in the near future. First off, I would like to give you an overview and status update of the current situation of Ysun Alliance. So first, an introduction to Ysun, for those of you that are not aware of who we are. Ysun Alliance is a global ecosystem of member companies seeking to accelerate the adoption and implementation of open standards-based field area networks, home area networks, and other Internet of Things applications. We develop communication profiles and a testing and certification program to support interoperable, reliable, and secure products. Since our beginning in 2012, we have become an established leader enabling innovative, smart solutions. We're delivering communication solutions both for large-scale outdoor networks as well as shorter range in-building networks. The benefits are that this promotes multi-vendor interoperability, which gives vendor competition and customer choice. We have now grown to be 300 members in 46 countries. This is enabling a diverse ecosystem of solution providers, which include product vendors, silicon vendors, cities, utilities, government institutions, and academia, all collaborating on smart solutions. We deliver a robust certification program to ensure interoperability for wireless devices, both for outdoor field area networks and home area networks, as well as a range of other IoT network applications. The target applications which we support include smart utilities, advanced metering infrastructure, peak load management, and now growing into distribution automation in addition to the smart metering applications. Smart cities, based on street lighting Canopy network, Ysun networks can support additional functionality such as infrastructure management, smart parking, environmental sensing, traffic and transport systems. Smart home, derived from the TEPCO Route B communications profile we developed. We've since enabled smart thermostats, air conditioning, heating, energy usage displays, as well as health and well-being applications. And we're seeing growing interest for Ysun in other machine-to-machine applications, such as agriculture, structural health monitoring, such as monitoring building integrity in bridges, as well as asset management. As I mentioned before, we now have over 300 member companies representing 46 countries, and this membership has continued to grow even through the COVID pandemic. Ysun membership provides a complete ecosystem from silicon to solutions. In addition to silicon, module and product vendors, as well as software providers, there are a number of other supporting services, including testing and certification, design, and software platforms. Navigant Research, now part of Guidehouse, estimates there are more than 100 million Ysun-capable endpoints deployed worldwide. A large number of these supporting smart utilities in terms of smart metering infrastructure, but additionally there are a growing number of networks deployed for smart street lighting, which I will describe a little later. I'd like to give you an overview of the Ysun technical profiles. Ysun Alliance has developed profile specifications to support a number of applications including smart cities and utilities. This slide focuses on two of those profiles. These are communication profiles, both of which are based on 802.15.4G and support IPv6 using 6LoWPAN adaptation layer. The profiles are the field area network profile, which supports large numbers of devices using wireless mesh technology, particularly suitable for large outdoor networks, and the home area networking profile, which has been adopted by TEPCO for their Root-B implementation and also supports other home area network functionality. The FAN profile has been adopted both by IEEE as a standard and TIA as its own standard, whereas the home area network profile has been adopted in Japan by TTC as TTC JJ300.10. We'll describe a little bit more of these profiles later on. Firstly, I'd like to give more of an overview of the Ysun FAN profile. Specification was developed as a technical specification and certification program for large-scale IoT networks, including smart cities and smart utilities. The requirements and features were that it gives excellent coverage, massively scalable to millions of devices, provides enterprise-grade security, and delivers resilient and reliable communications. In addition, it should support a multi-service network. In other words, it is possible to run multiple different applications concurrently over a Ysun FAN network. The technology is IPv6 over 802.15.4G wireless mesh. In addition, it is a global standard supporting APAC countries, the European, Middle Eastern and Africa, Latin America, as well as North America. What are the key use cases for Ysun FAN? This slide shows just a few of them. As I mentioned, particularly important for smart utilities and smart cities. So these applications include smart metering, EV charging, transportation, SCADA systems for the utility, as well as growing interest in support of distributed generation. So that would be supporting solar panels, solar farms and smart inverters, as well as wind turbines. Within the city, a street lighting canopy network, a smart lighting network can support parking, traffic management and environmental sensors in addition. If we take a look at the Ysun FAN network topology, as you can see from this slide, the connection from the edge devices on the network is through the Ysun FAN mesh and then through a border router device, which will then connect through the backhaul network to the network operations center. Backhaul could be cellular, fiber, Ethernet or Wi-Fi, or in some cases private networks such as WiMAX. And there can be multiple Ysun field area networks co-located i.e. operating in the same geographic region, but running by different operators. And similarly, there could be several connections onto the same backhaul network from the mesh, providing the opportunity for redundancy. As you'll see, the applications mentioned in the previous slide are included here, such as the AMI and EV charging infrastructure. But there's also some additional here, including structural health monitoring and a growing interest in agriculture. I'll now describe how the FAN mesh network topology works with a smart city application. Typical application for cities will be smart street lighting, with communicating street lights that allow the city to monitor and control. As the street lights are installed, they can communicate through the border router onto the backhaul network to the local authority office. The connectivity can either be direct between the streetlight and the border router, or if poor connectivity is not available, then nodes can use multi-hop connectivity, i.e. hopping through one of their neighbors to provide reliable service. Later, the city may choose to incorporate traffic signals onto the same network. These traffic signals can communicate, again, either with the street lights or with the border router or both, providing connectivity and visibility to the local authority office. Local authorities may also wish to install other smart city sensors and actuating devices. These could include smart parking, environmental monitoring, garbage monitoring, and a whole range of other applications. These devices would typically be battery-powered devices, and they would connect as leaf nodes to either to their nearest street light or to a traffic signal. I'd like to talk a bit about Ysun testing and certification. Certification delivers interoperability. Ysun could be thought of in a similar way to the Wi-Fi Alliance. Wi-Fi acts as an industry alliance, running a testing and certification program for a standard called 802.11, which is wireless LAN, and delivers interoperable products, particularly for office equipment and other local area networking products, so printers, computers, mobile phones. And the good thing about Wi-Fi is it just works. Wherever you go, you can use your phone, your laptop, and you expect it to work. Ysun Alliance is delivering a similar testing and certification program, but for devices that support 802.15.4G, or wireless smart utility network devices. So the scope of the organization is a little different, but the goals are the same. And Ysun certified products will be interoperable, whether they be smart meters or traffic signals, distribution automation equipment, or smart street lights. So Ysun Alliance is the certification organization for the large-scale IoT networks. Our certification program is developed and supported by our test lab members. These include the companies shown here: Allian, Eldorado, Gemic, Telec, and TÜV Rheinland are all Ysun approved test labs. Some of the benefits of Ysun FAN certification. For utilities and cities, certification ensures interoperability, which results in an accelerated time to market. It brings the benefits of a large ecosystem, reducing the risk. Because Ysun profiles are based on open standards, then you're guaranteed that there will be a longevity of products. They're non-proprietary, which means no vendor lock-in, interoperability, and ultimately faster time to market and cost savings, not only for the customers, the utilities or the cities, but also for the product developers. We look at our certified product growth over time. From the beginning of the certification program for TEPCO Route B, which was in January 2014, we have grown to a total of over 250 certified products. We look at the FAN certified products. They're now available from multiple vendors, and we're looking at more than 50 products from more than 20 different vendor companies. And this continues to grow week on week. We've produced an interoperability demonstration video. Originally, we did a live demonstration at an exhibition in January 2020 called Distributech, where we showed multiple devices from a number of different vendors forming a network and routing messages, and these occurred live on the exhibition floor. Obviously, we haven't had the opportunity to do the live demonstration at an exhibition recently, but we have produced a video and the link is shown below. So please take a look at the video. And we are continuing to grow the scope of the video and the number of products included within it. Let's put all of this into practice. It's worth noting that Ysun has quite a few utility member companies who are listed here. From the very beginning, Ysun has offered strong support for utility smart grid communications, which has been recognised by all of these utilities listed. Hawaiian Electric Company specified Ysun Field Area Network, Ysun FAN, to enable them to support their grid modernisation program. This allows them to interconnect devices on their smart meter network with devices on their distribution network, such as secondary line monitoring and volt var management devices. In addition, it allows the deployment of another standards-based technology called OpenFMB, which provides connectivity across the whole of the network. AMI-based outage management is a key use case for field area networks in the utility industry. For the case of Pacific Gas and Electric, they estimate that they have saved $2.5 million a year purely on the costs avoided by using smart meter outage information, which they can get through their mesh network. Connected with outage management is also power restoration, particularly after storms. Florida Power and Light recognize the value of deploying wireless mesh networks, which enable them to detect where there might be outages and help restore the power quickly and effectively. Avangrid, for their deployment in New York State, have developed an interoperability strategy that relies on open standards-based communications technology and application data semantics. As you can see from the diagram below, Ysun Fan is a key part of this strategy, allowing them to deploy products from multiple vendors that will reliably interoperate. Iberdrola and Avangrid have been Ysun members since 2018 and are actively contributing to the development of the next phases of field area network communications. Korean Electric Power Company is embarking on a large-scale IoT digital transformation that includes Ysun Fan as a key part of its communications infrastructure. The City of London has recently replaced an aging communicating streetlight network with a Ysun Fan capable network, and they are now connecting additional sensors, as shown in this slide, onto the same network, giving them the ability to collect data and metrics on things like traffic flow, pedestrian usage. This slide shows the previous deployment across the City of London. They have replicated this with a Ysun Fan capable network, providing highly reliable connectivity through some of the most difficult urban terrains. There is more information available at these links here, including an interview with Giles Radford, who was the project manager for the City of London. Ysun Alliance strongly believes in industry collaboration to help deliver on our goals for interoperable solutions. As you can see from the diagram, we have strong relationships with a number of organisations, including TTC, Econet Consortium and JUTA. This brings me to the end of my introduction to Ysun Alliance and our current status. Thank you very much for your kind attention.